Let us take in group 17 chlorine gas Cl2. Let's first discuss its preparation. In lab, it is prepared by the action of concentrated HCl on MnO2, which forms MnCl2 and chlorine. So this is how it is obtained, and plus water, of course. So we can get chlorine here in this as a byproduct. In place of HCl, we can use, yes, sodium chloride and concentrated sulfuric acid. The reaction is very same, and we get chlorine, of course, plus water. It can also be obtained by the reaction of HCl with potassium permanganate, it's KMnO4. What we get is KCl, MnCl2, water plus chlorine. So these are its usual lab methods of preparation. Industrially, it is prepared by a process called Dakins process, in which HCl is oxidized in presence of cupric chloride to chlorine and water. Also, it can be obtained by electrolysis of brine solution, where we get chlorine at anode. So these are its normal usual preparation methods. Now let us discuss its properties. Remember, it's a greenish yellow gas, which is basically odorless, but yes, when inhaled, it gives a pungent uncomfortableness. It is highly soluble in water, and when passed through water, it shows disproportionate reaction and forms HCl and hypochlorous acid. This hypochlorous acid then further decomposes to give HCl and nascent oxygen. That is why this chlorine, because of this nascent oxygen, is also used as a germicidal and fungicidal or as a disinfectant in the swimming pools and in other. And we also use this chlorine tablets in the drinking water, basically because of this reason. Now let us see its other chemical properties. See, it's a very good oxidizing agent. It can oxidize the species like, we are discussing its oxidizing reactions. It can oxidize ferrous sulfate in presence of sulfuric acid to ferric sulfate and HCl. Similarly, it can oxidize sodium sulfite solution, aqueous solution, to sodium sulfate and HCl. Also, it can oxidize sulfur dioxide aqueous solution to sulfuric acid and HCl, as well as iodine aqueous solution to iodic acid and HCl. So all these are its reactions in which it is very clearly seen that it is acting as an oxidizing agent, and itself is getting reduced to -1 oxidation state.